Okay, lesson 99 is more about sequences and means. Whenever you have a geometric sequence, you can always find the common ratio by dividing any term by the term before it. In general, if the geometric progression has the following terms, t sub 1, t sub 2, and so on, any fraction formed by dividing a term by the one before it will equal the common ratio. And if you think about it, that makes complete sense, because if you have something like, if you have something like the geometric sequence 2, 6, 18, and so on, you can see there that the common ratio is 3. You're multiplying by 3 every time. And what this is saying is that if you have a sequence and you don't know the common ratio, you can figure it out just by taking any term and dividing it by the term before. So in this sequence, if I take 18 and I divide it by the term before it, which is 6, I'm going to get 3, the common ratio. Or, for example, if I take the term 6 and I divide it by the term before it, which is 2, I still get the common ratio. So it doesn't matter which term you pick, but any term you pick, if you will just divide it by the one before it, you will get the ratio, the common ratio that relates every term in that sequence. All right, so if I want to find the 10th term in this geometric progression, the first thing I have to do is find the common ratio, and I'm going to use that procedure to find it. The 3 terms they give me are x, the square root of 2 times x squared, and 2x cubed. So to find the common ratio r, I'm just going to take one of the terms. I'll just take the second one, square root of 2x squared, and divide it by the term that comes before it, which is x. All right, so one of those x's cancels, and I'm just left with x times the square root of 2. That's my common ratio. And the question says to find the 10th term. Remember, the 10th term of any geometric progression is equal to, so I want to find the 10th term, that's going to be equal to the first term, which is x, times the common ratio, which we just found out is x times the square root of 2, raised to the 9th power. It's always one less than the term number. So I've got x times x to the 9th times 2 to the 9 halves. All right, and another way to write that would be x to the 10th times, 9 halves is 4.5. So 2 to the 4th would be 16, and then you'd have another square root of 2. So I would probably write it 16 x to the 10th square root of 2, but it's pretty ugly no matter how you write it. All right. Hopefully that makes sense so far. Okay, this next one has 3 terms, 2 plus the square root of 6, 6 plus 2 square root of 6, and 12 plus 6 square root of 6. And we're supposed to find the 4th term. But first we have to find r, and we're going to do that by dividing one of the terms by the term that comes before it. Okay, so I'm going to take the second term, 6 plus 2 times the square root of 6, and divide it by the first term to find my common ratio. All right, since that is a fraction that has a fraction in the denominator, a radical in the denominator, I need to multiply the top and the bottom by the conjugate of the denominator. Remember that when we have some kind of binomial in the denominator with a square root in it, we want to multiply that numerator and denominator by the conjugate of the denominator. So 2 plus square root of 6, I'm going to multiply by 2 minus the square root of 6. And that's so that I'll get a difference of squares in that denominator, and I won't have a square root anymore. All right, first of all, I'm going to multiply the numerators. 6 times 2 is 12. 6 times negative square root of 6 is negative 6 square root of 6. 2 square root of 6 times 2 is 4 times the square root of 6. And then I have minus 2 times 6, which is 12. And then in the denominator, I have a difference of squares, 2 squared, which is 4, minus the square root of 6 squared, which is 6. All right, so you can see that those cancel, and I end up with negative 2 square root of 6 divided by negative 2, which is just the square root of 6, which is my common ratio. So if I want to find that fourth term, I can just multiply the common ratio by the third term, because that's how you get from term to term in a geometric progression. So square root of 6 times the third term, which is 12 plus 6 square root of 6, is going to give me 12 times the square root of 6 plus 6 times 6, which is 36. So that's going to be my fourth term. Okay, this problem says that a ball is dropped from a height of 81 inches. On each bounce, the ball rebounds 2/5 of the distance it fell. How far does the ball fall on its sixth fall? Okay, so I'm going to draw a picture just to make this very clear. On the first fall, okay, a ball is dropped from the height of 81 inches. On each bounce, the ball rebounds 2/5 of the distance it fell. How far does the ball fall on its sixth fall? All right, I'm going to draw a picture just to make sure we understand what's happening. All right, so the ball falls 81 inches to start with. And so when it bounces back up, though, it only bounces back 2/5 of the way because it loses some of its energy when it hits the ground. So it hits the ground and it bounces back up. And I'm going to draw it as a slanted line because that way you'll be able to see it. But that's not really how it falls. It just goes, I mean, that's not really how it bounces. It bounces straight back up. All right. So 81, this time it only bounces back up 2/5 of that original 81 inches. And then it falls back down again. And then on the third or the second time it bounces, it only that's not that long. It only bounces up this time 2/5 of that distance. So 2/5, and I know it's not to scale, but 2/5 of 2/5 times 81. And then it comes back down. And then on the next bounce, it only bounces up 2/5 of that it bounced up before. So each time it bounces, it's only 2/5 of what it was before. So that's just a geometric progression where the common ratio is 2/5. So the first term, or I guess we'll call it a sub 1, since that's what I usually do. A sub 1 in this geometric progression is 81, and then each time the next fall is going to be 2/5 times that, because the next bounce is 2/5 times that, and it's going to fall as far as it bounced. All right, so 2/5 for that ratio, the common ratio. So if I want to know how far it's going to fall on the sixth fall, I can just take the first term and multiply it by r raised to, and this is a sub 6, to the fifth power, because it's always one less than the term you're on. All right, so if I punch that into my calculator, it's going to be 81 times, let's see, I'll just do the 2/5. 2 divided by 5 raised to the fifth power times 81 is going to be 0.82944 inches. That's how high it's going to bounce. Well, that's how far it's going to fall also on the sixth fall. Okay, now we're going to look at arithmetic and geometric means. We've already talked about problems where you find a certain number of means between two numbers, but now we're just going to talk about finding one mean between two numbers. And when we do that, if we're in an arithmetic sequence, it's called the arithmetic mean. If it's a geometric sequence, it's called the geometric mean. All right, I'm going to show you that the arithmetic mean is the average of two numbers. And that's the reason we call the average between two numbers the mean. We were referring to the arithmetic mean. All right, and I'll show you why. If you have two numbers, x and y, and you want to find the arithmetic mean between them, and you're dealing with a sequence that is an arithmetic sequence, then D is the common difference in that sequence, the number you add each time you're going from term to term. And so that mean, that number between the two numbers, is equal to x plus d. That's one way you could name that number. Another way you could name that number would be to say y minus d, because if you take d away from y, you get the number before it. That's also m. So if I add these two equations together, x plus y is equal to 2m. If I divide both sides by 2, then you can see why the mean is just the average of x and y. So whenever you're trying to find the arithmetic mean of two numbers, simply take the average of the two numbers, add them together, and divide by 2. Okay, the geometric mean of two numbers is something different. It's not the average. So just because you see the word mean doesn't mean you're talking about the average of two numbers. The geometric mean is something different. All right, so if I'm going to find the geometric mean, or what we call the mean proportional between two numbers, I'm talking about the number between them if you're dealing with a geometric sequence, which means that you multiply each term by some common ratio, r, to get from term to term. All right, and so what that means is here that if these are your three terms, a sub 1, a sub 2, a sub 3, all right, the first three terms, then the third term is equal to the first term times the common ratio squared, right? That is the third term. That's the way it works with a geometric sequence. You multiply by r every time, and so whatever term you're on, you multiply by r that many times minus 1. All right. So if I divide both sides of this equation by x, then y over x is equal to r squared. And therefore, if I take the square root on both sides, I'm just going to go ahead and erase that and take the square root on both sides. I'm going to get this for r. So if that's my r, and I want to find that geometric mean is the second term. So a sub 2 is going to equal the first term times the r. So times plus or minus the square root of y over x. And to simplify that, I can rewrite x as the square root of x squared. That means x. And then I'm going to multiply that by r. And so when I do that, I can multiply the numbers under the radicals together. So I'd have the square root of x squared y over x, which is just plus or minus the square root of xy. Right? So whenever you have two numbers, the geometric mean is equal to that. That is the mean proportional, plus or minus the square root of the product of whatever two numbers you're dealing with. Okay, so now you've got the positive geometric mean of two numbers is 8, and the difference between the numbers is 30. Find the numbers. All right, well, if the positive geometric mean of the two numbers is 8, that means that the square root of the product of the two numbers is 8, because that's what we just talked about the geometric mean is, and it says positive only, so I'm not putting plus or minus. And then it says the difference between the two numbers is 30. So I've got this system of equations, and I'm going to solve it for x and y. So if I solve for x here, I'm going to get x equals y plus 30, and then if I square both sides there, I'm going to get xy equals 64. So I'm going to use substitution to solve this system of equations. I'm going to substitute this in for x. So I'll have y times y plus 30 is equal to 64. Go ahead and multiply it out and move the 64 over to the left side of the equation and then factor it to solve it. All right, so you've got y and y. 64 is equal to 2 times 32. So I can put 2 and 32 here. And that would be, for the 2 would have to be negative, and the 32 would have to be positive, so that it adds up to positive 30. So because of that, if two things are multiplied together and give you 0, that means one of them must be 0, which means that y would have to equal 2. 2 minus 2 is 0. Or y would have to be negative 32, since negative 32 plus 32 is 0. So we have two possible pairs of numbers that will work here. We've got one where the y is negative 32 and one where y is 2. So if I go back up here and I find out what x is, that would mean that negative 32 plus 30 would be negative 2 for x, and then if y is 2, then x is 32. So there are two pairs of numbers that have the geometric mean, the positive geometric mean of 8, and that add up to, or whose difference is 30.